All right. So let's take a look here. All right, so we've got a quadrilateral PQRS, and it's inscribed in a circle, right? All the vertices are touching that circle. Okay. And we want to find the value of y. All right, so if you look here, we have a few angles that have y in them. All right. How should we kind of start here in order to set up this up though? Where should we kind of start? Any ideas? Where should we start? Yep, Stephanie. Okay, so which two opposite angles are you talking about here? Okay. Okay, and so what should be true about these two angles? Should we set them equal to each other? No. Which means they... There you go. So let's add them up. Okay, so 5y plus 3 plus 15y plus 17 equals 180. Okay. For those of you guys that like algebra, this is a very algebra-intensive, or at least algebra applicable here. Okay, you're going to use quite a bit of algebra. All right. So then at this point, Julia, what do we do now? Combine like terms. That's right. So what are we going to end up with here? 20y plus 20 equals 180. Good. And then what, Julia? Yep. So equals 160, and then divide both sides by 20, and yeah, we get y equals 8. Okay. So we found y, but then it says find the angle measures of each inscribed quadrilateral. So that means we're going to find all the angle measures here. All right. So now we've got the y. All right, Adam. How can we find those individual angle measures?
Just plug it in.
Yeah, just plug it back in. Okay. So angle P then. Let's see here. 8 is for the y, so we plug that back in. 5 times 8 is 40, plus 3 is 43 degrees. Okay. Angle R is, let's see here, 15 times 8 plus 17. I don't know why I'm writing this one out, but I didn't write angle P out. It's weird. Okay. Anyway, there it is. Let's see here. 15 times 8, 80. 120 plus 17, 137. I guess that should make sense because 43 and 137, what do? They have to 180, right? P and R, they're opposite each other in an inscribed quadrilateral, so they should have to 180. Okay, good. Angle Q, we have a square there, but we aren't scared of that because we're just plugging y in. So we plug 8 in. 8 squared is 64, plus 53 is 114. And then how can we find angle S? There's no y there, Adam. What can we do? There's no expression for it.
If you take 117 degrees from angle Q, subtract that from 180.
Oh, was it 117? Did I add up wrong? 50. I did add up wrong, didn't I?
Yeah.
117. That's an easy fix. There it is. Okay. Haha. Angle S, yes, is 180 minus 117. And let's see here. That is 63. Okay. Sure enough, there it is. All right. Easy peasy. Easy peasy. Okay. Questions on any of that? So again, the key there is to set up that relationship. All right, let's flip the paper over here. All right, let's try this next one. Actually, we're probably ready here. Go ahead and try your turn. I think you guys got this. We'll do this one. Go ahead and try number 5 right there, okay? Give that one a shot. I feel like we don't need to spend the time on that next one there. Let's give that one a shot. Yes, I should do it 2 here.
Let's see here. So you don't want to add, like, it looks like you added the same. Oh yeah, I see what you're saying. Yeah, it's not. It's opposite angles. You added these two, but it's opposites.
Opposites that are supplementary. Opposites. Did you find it? I think you got it. Okay, sorry. Okay, there you go. Awesome. Thank you.
You have all three of these. Only the opposite. So we look here, it's the opposite. Opposite angles are supplementary. You just gotta add up opposite angles.
Yeah. Only opposite. Yeah, that number's not nice. Yeah. Because of the
Noise is good.
All right, so Melissa, you want to tell us what'd you get there? Okay, Z is 10, so therefore angle T is 115, U, V, and W. Yeah, there you go. Okay, good job. That's right. Very basic, very straightforward here. Okay. Nothing too crazy. Questions on any of that? So just be careful you set up, again, the opposite angles there. The opposite angles that are, in fact, the supplementary ones. Okay, those are the opposite ones. Okay. We're not going to worry about doing the constructions there on the next page, so we can kind of forget about that. Then that's that for that little section, okay? So you can hold on there. I'll assign you some problems in just a second, all right? But we're going to skip on to that other section I wanted to talk about. So if you would, please go to now page 873. Okay, we're going to jump around a little bit more here. And we're going to look at something that's related to arc length. Okay? So yesterday we talked about arc length, which is like a part of the circumference. And today we're going to look at something called sector area, okay, which is part of the area of a circle. It's kind of like a wedge, like a piece of pie, almost like a, piece of pie, okay? Sometimes too big of a piece of pie, but you get the idea, okay? So we can talk about like a sector area, okay, where two radii are the kind of like edges of that sector, okay? So here you can see a sector of a circle is a region bounded by two radii and their intercepted arc. That is like the arc kind of like between them there. So it creates a little pie wedge, okay? So in order to find the sector, for example here, of AOB, okay, well, it's a fraction of the full circle's area. So how will we go about finding the area of that circle there? Mary, what's the area for a circle again? Do you remember?
It's pi r squared.
Yep, pi r squared. So in this case then, the r is what?
15
Yeah,
millimeters.
yep, 15 millimeters. So I'll just plug in 15 there, and we're going to square that. Okay. Okay, so we get then that the area is pi times 225, or we could say 225 pi normally. And of course we could, if we wanted to, make that pi like 3.14. It doesn't actually, does it say? Express your answer in terms of pi. Never mind. So there we go. So we found the area here in terms of pi. Now that's the full area though, right? But we're not interested in the full area. We're interested in this sector. So Mary, what fraction of the circle is that?
1/3.
How'd you know it was 1/3?
Because 360 divided by 1 is 1/3.
Yeah, okay, so 120, okay, 120 is 1/3 of that full circle. So if we take this area of the full circle, what should we do to this area then, Mary, to get the area of that little sector?
Multiply it by 1/3.
Yeah, exactly right. Multiply by 1/3. 225 pi times 1/3 then should yield the area of that sector, okay? And so let's see here. Ooh, that should actually work out nicely. So 225 divided by 3, 75. So 75 pi millimeters squared, we'll say, is the precise area, okay? I don't know if we talked about this yesterday, but this is called leaving your answer in terms of pi. Have you guys seen stuff like this before? We had to leave your answer in terms of pi. The nice thing about when you leave it like this is that it's a nice number. It's precise. Like every time you round, you lose some precision, right? Anytime you round something, you're losing precision, okay? Because pi goes on forever, never repeats, and so anytime you round pi and say 3.14 or even the pi button on your calculator, you're losing some precision. Now, granted, you might not care how much, whether your precision is good enough, okay, or not, but because I think someone told me that. I feel like I remember reading recently that in order to accurately calculate the circumference of the universe, you only need pi out to 20 decimal places, and then it's that's good enough. So people that memorize pi out to 100 digits or something like that, it's overkill. I mean, granted, it's impressive. I understand it's competition and stuff like that, but for ginormous calculations like the size of the universe, even we really only need about 20 digits of pi, and then we can be very accurate with that. Anyway. Here, though, for our calculations, it's nice and it's precise when we write it that way. If we wanted to, we could multiply the pi through, and we would get about 235, and this time I'll use the squiggly equal sign for the approximation. 235.6 millimeters squared there, approximately. Okay, so either one's acceptable, I think, in this case, and rounded to the nearest tenth. So yeah, I wanted both. Okay, so there it is. And so, in fact, in a more general sense, if we flip our paper over here, you can see the area of a sector is very much like that arc length formula that we had, okay? You'll notice here if I just block off, there's the area formula, just like for the arc length we have the circumference formula, all right, but then it has this m over 360 for the measure of the arc. And that's it, okay? So we'll just kind of run through these two examples here real quick, and then I'll have you guys try one, and then that's it. We'll be done, okay? So real quick here, we'll look at, I'm not even going to do this one because it's already done out for us, and I know sometimes I'll still do it. We'll just look through it here real quick. But you can see here, for example, sector POQ, which is kind of interesting. Anyway, they chose this darkened region here. So 210 degrees goes over 360 because that's the measure of the arc there. 3 is the radius, and so you just plug it in the formula there, multiply it out, and you get 21 pi over 4, which is the same thing as about 16.49 inches squared. Okay. For letter B here, okay, this one has got some blanks for us to fill in, so let's see if we can fill these in without getting too confused. Let's go to Tanner, okay, so what should I put over the 360 for letter B here for sector HGJ?
131.
Yeah, 131, that's right. Okay, what about for the R?
12.
Yep, 12. Exactly right. And so then it looks like, can we simplify that 131 over 360? I don't know. Looks like no. Looks like it does not simplify. So we'll just leave it as 131 over 360. Okay? But we can make that 12 squared 144. And then I think that might simplify the 360. I know these both divide by 12. That'll be 12, and that'll be 30, I think. Yep. Oh, and 12 and 30 simplify some. So let's see, I can divide out a 6 there, and that leaves me with 15. Oop, but then I can divide a 3 out, so 2 and 5. So it looks like 2 times 131, so 262 over 5 pi. I think that's it. And so then we type that in. Oop. And then I get about 164.6 meters squared when we do all that multiplication. Okay. All right, so 164.6. All right, so why don't you guys try Oh, question, Stephanie.
How come the first problem we didn't do with the one?
Ah, okay, we didn't do our 360. Very good, very good, very good. We put a 1/3 in front here, didn't we? Okay, and you'll notice though, so what should we have written? If we use the formula, Stephanie, what should we have written then? 120 over 360. But let's simplify that 120 over 360 to 1/3. Exactly right, exactly right. Yep, exactly right. But I'm glad you asked that, so now you can see they're the same thing. All right, let's have you guys try number 5. Try number 5, please, and your turn. Okay, number 5. Number 4 I think is too easy. Number 5 is probably too easy too, but okay. It's a little bit different.
I think I started it right? But now,
Mm-hmm.
I get that.
So that's like multiplying, so you see the pi is left out. So if you like just then simplify this, if you do 1/16 of 576, because this is all multiplication, you can multiply these two together and still be the same.
How like, do I like do that?
Yep. Mm-hmm. So 576 over 16, which you can simplify. It actually does work out rather nicely. So. Okay, yay, good job. Yes. Mm-hmm. Okay. All right, Julie, what'd you come up with there for number 5?
I got 113.1 millimeters.
Yep, looks good to me. Questions on any of that from anybody here? All good? Okay, so I think that's it. Yep, that's it. Okay. So, cut the video.